So welcome to the microConf. My name is Marek, and today I'm honored to introduce you our iOS world in SwingDev. Before I start, I would like to shortly introduce myself, because it can give you some insight why I have decided to reveal our iOS secrets from SwingDev. I am a programmer more than 20 years. I've started with C++ and Java, and in 2010 I've switched to iOS programming. I remember my main problem then was I didn't know anyone else who was working on the same things. That's why my first application was the mix of my Java application architecture, Apple documentation, and Stack Overflow hints. Some years later, actually 5 years ago, I moved here to newly founded SwingDev company, and here we've created iOS team. In this team, we could exchange our iOS experience. And finally, we have worked out quite good application architecture, which helped us to create many beautiful applications. Today, every new team member goes through small introduction into our solutions, and we would like today to share this introduction with you. So, if you're looking for good recipes for baking iOS applications, we would like you to spend next 20 minutes like you were our new team member. So, what I'm going to show you today, first I will show you application pattern we use. Then I will show you how we share data and services between all application components. Then I will show you how we create views. And finally, I will show you some tools we're using. But first, what we don't use in our application architecture. Maybe you recognize this diagram from Apple documentation. If you ever tried to create applications in the manner Apple suggested, you could notice that this was never a real Apple. This Apple MVC was never a real MVC, but more Elm with VC, because UIView controllers in this pattern takes responsibility for view and controller. So they take too many responsibilities in their body, and this makes them big files, massive files, hard to test and maintain. Finally, Apple withdrew from this recommendation, and now you can read that this document may not represent the best practices for current development. So what we use instead of this currently outdated Apple MVC, it's nothing special, it's just a very popular model view model pattern. I know there are some iOS interpretations of this pattern, and I would like to show you how we solve this in our applications. Let's start with view component. As view component, we perceive not just UIView, but also UIView controller. And this is the main difference, because now UIView controller can focus just on view part. And another component, model, is actually the same as it was in Apple MVC, because it represents data layer of the application. And finally, the most important, view model. View model is mediator between view and the model. View model is responsible for translating data from model part into something what view can understand and represent on UIView. And in the opposite side, view model is also responsible for translating user actions from view part into something what model will understand. So, for example, for data changes. The communication between view model and view we resolve by binding UI controls to view model properties. The communication between view model and model we resolve by sending updates to model and by listening on model data changes on model side. For all this communication, we usually use RxSwift library or asynchronous methods. I will return to RxSwift library because I assume not all of you are using it. So as you can see, this pattern looks simple, but this is just diagram with overview concept. Let's take a look how we solve this in our source code. Let's start with simple use case. So like simple login screen. We have two UI text fields, one button, and there's three fields. Actually, two fields and a button are our inputs from user. And one, additionally, we have a label for showing error message. And this one is just output from user, from view. Each output for user. And let's see how your UI view controller looks. So our login view controller, as you can see, it has all your UI controls, and it doesn't matter if you're using interface builder or create UI views programmatically. This is the right place to keep properties for UI controls. And one important thing what we have in login view controller is that we also store here the view model, because UI view controller in MVVM pattern is the owner of view model. And good practice is to not use the final class of view model. We just use protocol, because it can give us easy way to define the interface between view and view model. And additionally, we can simply replace view model with mocked version of view model, so we can simply test it. Now, let's take a quick look how our login view protocol, login view model protocol looks. As you can see, for all user inputs and outputs, we have related property. And what is the type of this property? If you're not familiar with RxSwift, I will just shortly explain that it's something what you can read as, for example, for username field, you can read this as stream of strings. And like I told before, I assume not all of you are using RxSwift. That's why I owe you the short explanation, what is it? So, what is this RxSwift? RxSwift is Swift framework for very popular reactive programming. This kind of programming gives you different approach for working with asynchronous data streams. It uses observer pattern, where our actors in data flow can play one of two possible roles, observer or observable. First, an observer subscribes to observable, and since this moment, observable can emit three different event types: next, error, and complete. And for example, if you will just try to observe UI text field, when user will type short word ABC, we will receive three next events, and every next event will carry longer word, so A, AB, and ABC. In our example, we are interested only in next events, but you can imagine another examples where we can really expect errors, or we need information about finishing the meeting, because a complete event means that a meeting has been finished and you will not receive any other events. Such example can be observing API responses. So, for example, when we want to know if request failed, we need to subscribe for the error events. And if we want to know that we will not receive anything more, then we can subscribe for complete event. And for example, we can use it in the moment when before sending request, when we start showing the spinner on the UI view, and we just want to close this spinner, no matter if it has finished with success or error. And now I would like to show you how we use this RxSwift for binding UI view controls with view model properties. We are in login view controller. In viewDidLoad method, we have to find the UI text fields, so it's easy because we have this in property. And now we need to get from this UI text field the observable type. And to do this, we use Rx Swift extension for UI text fields. So we just type Rx text, and now we have this observable. And this observable gives us a stream of strings. And now we can modify this stream of strings. And in our simple example, we just want to modify this stream to not get nil values. So this or empty means that if any new value comes from UI text field, we will map it to empty string. And finally, we bind this observable strings to viewModel property. So now it means that all strings from username field will be automatically redirected to this viewModel property. And finally, one more line is for cleaning after this binding. So for example, when login view controller will be closed, we just need to free all this binding, because do not leave retain cycles. And now I would like to show you another binding, but this time it's binding to the output. So this time we want to redirect our viewModel error message to our label, message label. So as you can see, it's very similar to the previous one, but this time we just inverted the order of components. And now I would like to show you how our model part looks in this simple example. And it's just protocol for network provider. And the only method of this network provider is login action. As you can see, this login action takes two parameters, username and password, and returns observable with login response. So as you can see, we use Rx Swift not just for UI stuff binding, but also for handling API responses. And this is how we can use all these observables from viewModel and send something to the server. Login trigger is the observable for login button. It's linked with observables for username and password combined together, and then when they are mapped to network action, this login action. So it means that every time when user selects login button, we take the latest values from username and password and send request to the network, to the server. So then we wait for next event with the response, or for the error message, error response. Now let's take a look how we create MVVM components for our example login screen. We should start with login view model, but this login view model requires data part, actually this network provider. So now we have both of them. And finally, when we have both of them, we can create login view controller and show it on navigation controller. And what this architecture gives us, we have three components completely separated with different responsibilities. So now, if we want to test one of them, we just need to replace all neighbors with mock versions, and we can test this part. So, for example, if we want to test view part, we can replace login view model with login view model mock. By the way, this is the best way to perform something what we call screenshots testing. This is our favorite method for checking if recent changes in code didn't cause unexpected changes on view. How does it work? We just save screenshot for desired view state, and then in future we do another one screenshot. Then we compare them using Nimble snapshots library, and if screenshots are different, test fails. Another benefit of screenshots testing is that we usually store all the screenshots in the one place, so we can easily show them to our design team. And we can ask them if what we did was what they expected from us. And now let's see how we could test login view model. We need to initialize login view model with network provider mock. And actually, we don't mock view part. We just invoke actions on view model. We just simulate view actions. And then we just check if what view model did is what it was expected, if it was expected what view model did. And now I would like to mention about another one problem in architecting the app. You already know that we use this MVVM pattern, and this is enough for defining the rules, the responsibilities on the one level of screen, on this one screen, the login screen. But what with the flow between this one screen and another screens? MVVM pattern suggests to put all UI stuff in UI view controller. But does it mean that we should also place this flow logic there? It would make this UI view controllers massive again. And we don't want to do this. That's why we use MVVM extended by a different pattern called coordinators. What are coordinators? Main responsibility of coordinator is to control flow between screens. It means the coordinator is responsible for creating UI view controllers, for showing them and hiding, and for injecting adequate view model with adequate data. Usually we don't create just one coordinator for all screens in our application. Coordinator should focus just on one group of screens which realize a single goal. For example, we should create separate coordinator for login flow and different one for showing user details. If we have more coordinators in the application, we need to join them somehow. That's why coordinator can contain another children coordinators for different tasks. All coordinators in the application with all their view controllers finally create tree structure. And so coordinators on this tree are branches, and UI view controllers are leaves. Now I would like to show you how we can build this tree hierarchy example application. Let's say we have a simple application where user first has to log into the application to see the content. In app delegate, we need to create the app coordinator, which is the topmost coordinator in this tree hierarchy. On next level, app coordinator can use one of two coordinators, login coordinator or tab bar coordinator, and he will use login coordinator if user is not logged in, or it will use tab bar coordinator if it already is authorized. So tab bar coordinator is resolved with UI view controller. It contains UI view controller, but not just UI view controller, but UI tab bar view controller. And let's say we have for all this, in this tab bar view controller, we have three sections. It can be user tasks, user profile, and application settings. For all these sections, we need another one coordinator. And finally, from tasks level and from task level we can add new task, and from user profile level we can upload image to user image. That's why we need another one coordinator just for these tasks. So as you can see, this is the simple solution gives us easy flow control. One of the biggest advantages of this solution is that coordinators are flexible, independent units, and we can easily move them from one parent to another one. And actually, you can reuse one coordinator from more than one parent. And this is how we control flow between screens in our applications. Now I wanted to tell you about the last key ingredient in our app architecture, We call it UpContext. And from MVVM pattern point of view, this is something on model side. It's responsible for providing all data layer services. So, for example, for databases, for keychain service, or for API. UpContext is just a struct, and in this struct we define protocols of services. We define protocols because we want to make it to be easily testable. And we usually create UpContext from UpDelegate when the application is launched. And then we share this UpContext between all coordinators in the application, beginning from the topmost App coordinator. The biggest advantage of UpContext solution is that it gives us easy way to get any data or any service from any coordinator in the applications. And usually, when we create MVVM view model, we initialize view model with selected data or services from this UpContext, or we can just pass all UpContext. Another big advantage of UpContext is that in every moment of application development, we can just replace any of provided services with another one. Actually, for example, when we have here core data solution as database service, and we can just implement Realm IO database, and it will be easy to replace it in every moment of the application. Of course, if we will implement this solution. And now, I wanted to tell you about how we build view layout and appearance in our application. For this, we use our own solution called SwingDev Style and SwingDev Layout. This is something not published yet by us, but we have such plan. So if you'll be interested in this, just let us know, and we will give you a sign when it is ready. So, what is SwingDev Style? This is way how we define the view appearance. For example, in our view, before class body, we define struct styles, and for every subview in this view, we define the appearance of this subview. So it can be background color, text color, font, if corners should be rounded, if it should show borders. Then we use this style when we create subviews. We can use this in this way because we have added extensions which translate the styles into adequate decorating actions. Since the moment we have started using it, it's much easier to change colors, fonts, and all this kind of stuff in Vue, especially that we can share common styles between more than one view. So what is SwingDev Layout? It's very similar to SwingDev Style, but this time, for every subview, we need to define the layout of subview. In our view, for every subview, we define what kind of layout constraint we want to add to this subview. We describe in specific layout style struct, where we can define if view component should align to the left or right edge, or if should be centered, and we can define the margins of this alignment. We can also define how it should behave when view is shrunk or expanded. Finally, when we create subviews, we use all these recipes for every of them. Of course, also in this case, we use UI view extensions, which translate the structs to adequate auto layout constraints. Why we use this solution? Because we have all view layout definition in one place, line by line. We can easily change it. We can expose some different layout styles and use them depending on the view mode. Or we can share common layout styles between more views with similar layout. Now, when you got used to use the SwingDev layout, we prefer this way of layout building than using interface builder. Now I would like to tell you about tools we are using in SwingDev. I will start with Dependency Manager. The first dependency manager we created for iOS and the first used by us was CocoaPods. I still think this is the simplest and most reliable tool. Almost all libraries are created with CocoaPods support. In some projects, we used Cartridge. The biggest advantage of Cartridge was that projects were built faster than with CocoaPods. However, I think there is too much manual work to set up this tool in iOS projects. Another problem is that it's still not supported by every library. And finally, Swift Package Manager has a big future, but it still doesn't support iOS. So we can only wait and remove it from our comparison. And in this comparison, for us, the winner is CocoaPods. That's why we still use it. And now, I would like to tell you about SwiftGen. SwiftGen is a tool for auto-generating Swift code for resources to make them type-safe to use. It generates enums, which we can simply then use in our code. We use it to generate localization enums and image enums. Sometimes we also use it for fonts and colors, but only if they are not auto-generated by our design tools, like Zeppelin. How to use this library? There is some configuration work where we need to add, where you need to add library, point the project resources paths, add script execution in build phases, but you do this only once and at the beginning. Then all you need to do is just to use generated enums to access your resources, like on this example. That's pretty simple and saves you a lot of time. Another very useful tool is SwiftLint. We use it to keep Swift style and conventions. Just in brief description, it shows you warnings if you put comma in wrong place, or if your method is too long, or if you use something in wrong way. If your variable is too short, you can define your own limits, your own warnings. Like for SwiftGen, you also need to do some configuration work, but then you feel more confident because you know that there is your own Swift guardian angel who really cares for your code style every time you build your application. So if you don't use it yet, we can encourage you to try it. And actually, this is all I wanted to tell you today. I hope it will give you some worth in your programming experience. Thank you. And if you have questions, my colleague will give you the mic. Oh, it's not connected yet.
Right now? That's working?
Yeah.
Okay. If anyone has any questions, if so, we have this super mic.
Which IDE do you use? The Xcode or the one from JetBrains?
Now we are using Xcode, and actually we were using UpCode some years ago, and actually when I started, it was still Objective-C. We were using UpCode, and it was much better than Xcode. But now, I remember that one day we have switched to Xcode. We have resigned from UpCode because it was too slow. I remember that we had a very big project with many source code, and we just wasn't able to use it, so we didn't have any choice. And when we got used to again to use just Xcode, we stayed with this solution.
Anyone else?
What's the refresh cycle after you change the, for example, layout definition to see the result on the screen or on the phone or on the emulator? What's the how fast or slow it is to develop in this way the user interface?
Sorry, okay. I didn't.
Because you have you want to change the layout.
Yes.
The view, yeah.
Mm-hmm.
You change the code, reload an app. The app. How fast is this? This compilation and reloading the view to see the effect of what you have changed in the code.
So actually, you're asking me about how much time it takes just for me as developer to.
You want to change something
Mm-hmm.
in the view,
Mm-hmm.
the view. Yeah, for example, a margin.
Oh yeah, now I understand. So it's just it's a question related to this SwingDev layout. Okay,
Yeah.
so it's very fast because you can just for example the margins we store all in one constant layout because it's usually shared between all screens. So we can just change this value and build. So it will take just the time for building, yeah?
And what's this time?
This
Of building and then seeing the effect on screen.
actually immediately, yeah? I don't know if you immediately we don't have to because we don't have if you will not actually I don't know if it's a reason. If
My question is because when you use the this visual designer for building the UI,
Mhm.
you see some
now I understand what you're.
almost
Yeah.
You see instantly the effect. Yeah.
Yeah.
And here, when you do this programmatically, then how long it takes to see the effect?
So the time for building.
And that's
So if
around.
it depends on the project. So we have one project which is very big, and it takes I don't know 8 seconds, but just for if of course if it's already cached and we don't have to build it from scratch.
Okay. It is some kind of hot reload of the app on the phone, or is within an emulator? How do you work daily?
We usually use devices, but of course, I prefer devices, but not all of us all time use devices. And if we can, if we don't have a device which is specific and we don't have it, we of course use simulators. And as I understand, it's still related to the question, to the first question. I mean, to the question about this layout. So actually, I don't know. I don't know how much time it takes to reload the application and put this again on device. I didn't measure this, but I think it's not significant because I don't remember this time. So it's not like I leave my desk and I go to I don't know, kitchen or toilet in this time. So so I think it's not significant for us.
Okay. Thanks.
Of course, as I understand your first question, because we don't use interface builder now. We stopped using because of this. Actually, because of this application we used. One day we have received the project, which was very huge, and we need to maintain this project and work something. And I remember that we had problem with opening very big zip files and storyboards, and then we simulated nodes. We were using this SwingDev layout, and this was the moment when we realized that even we have something in interface builder, but for example this margin, we have the same on 50 screens in the storyboard, because this was exactly the application which I'm talking about. And when I wanted to change this margin, I had to open all screens and change it on all of them. If we have a common shared style, we can just change it in one place and That's why we have decided to not use interface builder anymore. Or, of course, if we are prototyping or we have just simple applications, we still use interface builder.
Okay, so,
Thank you.
okay, so I'd like to add something to that. So I'm a part of mobile team too. I also wanted to add that we do use incremental builds, and those layouts are defined in the local file only, not in like some constant double file included in other files. So it's not those changes are only local. So usually it takes like just a couple of seconds, 3 seconds or so. And we usually, the layouts we implement are usually defined in some kind of tool like Stepnik or something. So we usually just take the margin and put the exact number into the code. So we don't usually have a lot of small like updates and compiles to. Thank you.
Okay.
Anyone else? Thank you.
Okay, thank you.
So I just have